Okay, this is lesson 1.4, Equations of Lines in Modeling for Mrs. Cucci's College Now Pre-Calculus class. All right, so by the end of this lesson, you'll be able to determine equations of lines. Given the equation of two lines, determine whether their graphs are parallel or perpendicular. Model a set of data with linear function and fit a regression line to a set of data, then use the linear model to make predictions. So those are the goals. All right, so we've already kind of talked about slope-intercept equations of lines. That's our y equals mx plus b. We know that the slope is represented by the variable m or the constant m, and our y-intercept is represented by the term b. Okay, we can very easily find the equation to such lines. You guys have been doing y-intercepts since junior high. Okay, so a line has a slope of -7/9 and a y-intercept of 0.16. Find the equation of the line. So we're going to use that slope-intercept form, y equals mx plus b. Okay. We know right away what our slope is because they basically spell it out for us. Y equals -7/9 x. And then what our y-intercept is the point 0.16. So as we know from graphing, 0.16 means I'm going to move over 0 and up 16. So our y-intercept is simply 16. So our equation is y equals -7/9 x plus 16. Okay. Line has a slope of -2/3 and contains the point -3.6. Find the equation of the line. Now this one's a little bit different. Okay. We're not given the y-intercept, but we're given a point on the line. So we need to find it from there. So we have an equation that hopefully you can think back and remember, and it's called point-slope form. Okay. And what point-slope form does is it allows us to determine the equation of a line giving the point and the slope. And that equation was y minus y1 equals m times x minus x1. And that does need to be memorized, guys. So if you don't have it memorized, which you all should already, you need to get it memorized. All right, so we know that -3 is our x and 6 is our y. We're going to simply plug that in. Y minus 6 equals -2/3 x minus a -3, which becomes a +3. And we're going to put it into y equals mx plus b form. I like it in that nice, pretty form. So in order to do that, we're going to have to go ahead and solve for y. So first thing I need to do is distribute. Y minus 6 equals -2/3 x minus 2, right? -2/3 times 3 is a -2. Last step is to add that 6 over. We get y equals -2/3 x plus 4. Now that's in our y equals mx plus b form. All right. So there's that point-slope equation, right? I must have put them on the wrong pages here. Y minus y1 equals m times x minus x1. You've used this before. You know how it works, so we're just going to practice it a little bit. All right, so now we're given 2 points and asked to come up with that line. So we have y equals mx plus b. We have y minus y1 equals m times x minus x1. But in order to use this equation, we need the slope. So that's our first step. Step 1 is to find that slope, okay? And we know the slope formula is change in y over change in x. So we're going to do y2 minus y1 over x2 minus x1, which gives us -7 over -1, or a +7. Okay? So first step, find the slope. Second step, we're going to utilize this point-slope formula right here. You could pick any point that you'd like to use. Either one is fine. I typically like to use the ones that are the easiest, and that's going to be the ones without any negative signs. So we get y minus y1 equals m times x minus x1. And again, you need to make sure that you put it into slope-intercept form. So you need to distribute that 7 and then add over your 3. Okay, so again, you're finding the slope, and then you are taking your point and your slope, plugging it into point-slope form, and then solving for y. Okay, next page. Okay, parallel lines. Well, we know that all vertical lines are parallel. Non-vertical lines are parallel if and only if. That's what that term means, okay? If and only if. They have the same slope and different y-intercepts. Okay, so parallel lines, they're parallel if they have the same slope and a different y-intercept. If they have the same y-intercept, you're talking about the same line. Okay? So perpendicular lines, on the other hand, those are two lines with slopes m sub 1 and m sub 2 are perpendicular if and only if the product of their slopes is negative 1. Okay? Product of their slopes is negative 1. So what that means is their slopes have to be negative reciprocals. Okay? Their slopes are negative reciprocals. Lines are also perpendicular if one line is vertical, x equals a, and the other is horizontal, y equals b. We call those orthogonal. Orthogonal means they create a 90-degree angle, which means perpendicular. Okay? All right, so we're going to determine whether each of the following pairs of lines is parallel, perpendicular, or neither. So in order to determine that, the first thing we have to do is make sure that they're all in slope-intercept form, y equals mx plus b. Okay? That's how we're going to determine the slope. And as we see it right now, we know that in A, they're not. So that's our first step, is to solve those for y. This one's simple. All we have to do is subtract over that 2. Okay? And the next one requires a little bit more work. So we're going to start by subtracting that x. And notice I'm keeping my x before my constant. And then we have to divide by 5. Okay? So if we're talking about parallel perpendicular, what we're concerned about is the slope. The slope is always the number that sits in front of the x. I've got 5 and negative 1/5. Okay? 5 and negative 1/5, those are negative reciprocals. Okay? Those are negative reciprocals. So this first one is perpendicular. All right, so let's try the next one. You're going to solve for y, and then you're going to find the slope. So I want you to pause the video here. I want you to try it and then come back. Okay, so we're going to solve for y again. So we're going to subtract over that 4x and then divide by 2. Remember, everything has to be divided by 2. Next one, it's already y equals, but it's negative y equals. So what we want to do is we want to divide everything by negative 1. So negative 2x minus 5. So if we look at the slopes here, we have a slope of negative 2 and we have a slope of negative 2. So these ones are parallel. Okay, these are parallel lines. All right, last one. 2x plus 1 equals y. We already know what our slope is. It's already set up for us. It's 2. Next one, we want to subtract over that 3x, and we have a slope of negative 3. These are not negative reciprocals. They are not the same, so this is neither. Okay, so hopefully we're clear on parallel and perpendicular. All right, write equations of lines A parallel and B perpendicular to the graph of the line 4y minus x equals 20 and containing the point 2, negative 3. So the first thing we need to do is we need to take this and we need to put it into slope-intercept form so that we know what the slope is, because then we can very easily come up with equations that are parallel and perpendicular. So let's solve that out. Add over that x, and then divide by 4. So we get 1/4 x plus 5. Okay? So the slope for that is 1/4. So we need the slope for a parallel and the slope for a perpendicular. Okay? We know slope for parallel is going to be the same. Perpendicular is going to be negative reciprocal. So the reciprocal is going to be 4 and then negative. Okay, so we've got our parallel and our perpendicular. So we've got the slope and we've got a point, which tells us we have to use point-slope form. Okay, so let's do parallel first. We have y minus y1 equals m times x minus x1. We're going to distribute. And then we're going to subtract our 3. Negative 2.5. Okay. So that's our parallel. Perpendicular. Y plus 3 equals negative 4, x minus 2. So the only thing that changed was the slope. Y plus 3 equals negative 4 plus 8. Y equals negative 4x, I lost my x, plus 5. Okay, so there's our parallel, there's our perpendicular. Okay, next page. All right, so mathematical models. What a mathematical model does, or how the steps for creating a mathematical model work, is the first thing you need to do is you need to recognize that the problem is actually a real-world problem. Okay? You have to then collect the data. You have to analyze the data. You have to figure out and construct a model. You have to test and refine or change that model so that it fits your needs. And then you have to explain and predict. So those are the steps we kind of follow through when we're creating these mathematical models that fit our real-world applications. So let's look at one. U.S. gross domestic product. The gross domestic product, or GDP, of a country is the market value of final goods and services produced. Market value depends on the quantity of goods and the services and their price. Model the data in the table on the U.S. gross domestic product with a linear function, then estimate the GDP in 2014. So what I did is I took a whole bunch of data and I put it on this next page for you. I've got in column A the years since 1980. So 0 would be the year 1980. 5 would be the year 1985. 10 would be the year 1990. Okay, it's the year since. GDP in trillions, so the gross domestic product in trillions of dollars, 2.8 in that year of 1980, 4.2 trillion in 1985, and so on and so forth. Okay, so what we need to do is we need to construct a linear model. Okay, so we know that generally speaking, what we do when we have a table of values is we like to create a scatter plot, right? So I'm going to hit Control I, and I'm going to put in my data and statistics. I know that my domain is going to be my years since 1980, and my range is going to be my GDP in trillions. Okay, so we get this really nice scatter plot that really, I mean, it looks pretty close to linear, right? So what we're going to do is we're going to use our linear regression option, okay? The calculator does a wonderful job of giving us a beautiful linear model that we don't have to mess around with. We don't have to add a movable line. We don't have to guess. We're getting a very good regression equation that we can utilize. So what we're going to do is we're going to go back here and we're going to find our regression equation. Menu, Analyze, Regression, and then we're going to show that linear. Okay, so we have y equals 0.405x plus 2.13929. Okay, so it is, you know, there's quite a few decimals to it, but if we're talking about real world, real life applications, that makes sense. We don't get pretty whole integers all of the time. So you have to get used to dealing with messy numbers. Okay. All right, so find the regression equation. Use this equation to determine the GDP in 2014. Okay, so our equation was y equals, and actually we should be talking in terms of t for time and then really money. But so y equals 0.405x plus 2.13929. Okay, so there was our regression equation, right? If I'm looking for the value in 2014, remember our years is determined by years since 1980, right? since 1980, with 0 being 1980. So 2014, we're talking, well, 1980, 1990 is going to give us 10. 2000 gives us another 10. 2010 gives us another 10. And then 4. So we're talking 34 years, right? So we're 34 years in. So with our variable for number of years being our x. Okay, so what we're going to do is we're going to substitute 34 in for our value of x. And notice I didn't change my equation. I didn't truncate anything. I didn't adjust anything. It is what it is. It's meant, these numbers are there for a reason, okay? So what I'm going to have to do is I'm going to have to take this and use the tools that I have, okay? And I get 15.9093. Okay? And remember that the money is in trillions. Okay? Good. Okay, so we found that linear regression, and then we utilized the linear regression to find the amount of money 34 years after 1980. Okay, so correlation coefficient, you guys have been talking about this since 9th grade. Correlation coefficient, or our R value, is a value between -1 and 1 that describes the strength of a relationship between two variables. So the closer we are to +1, the closer we are to linear with a positive slope. Closer we are to -1, the closer we are to linear with a negative slope. Closer we are to 0, the less of a relationship it has. So strong positive is going to be closer to 1. Strong negative is going to be closer to -1. Weak positive, weak negative is going to be closer to 0. Okay, so that's all we have today. So please make sure that you come prepared with any questions that you might have tomorrow in class. And I will see you then. Thanks, guys.